This is 2016 number 2, which is a calculator question. It says, for t greater than or equal to 0, a particle moves along the x-axis. So this topic is straight line motion. The velocity, they're giving us the velocity. The velocity of the particle at time t is given by this function. The particle is at position x equals 2 at time t equals 4. And that information will come in helpful next semester when we start talking about some stuff. It says, at time t equals 4, is the particle speeding up or slowing down? Remember, speeding up or slowing down has to do with the speed. And the speed's relation to velocity is that speed is the absolute value of velocity. So for part A, I can write that I'm looking at speed to equal the absolute value of velocity. So if I type this velocity function into my calculator, I get 1 plus 2 times sine of x squared divided by 2. All right, and then I can also actually figure out. Well, I'm looking at a specific value. I'm looking at t equals 4. So here's what I can do. Here's some cool things I can do. Let me go back to my home screen. Now, I showed you guys vars, y vars, that whole thing. We're going to use that with the absolute value function. So here's how you recall the absolute value. So if I can figure out that the absolute value of the velocity is a positive value, that means speed is positive and it's increasing. Or if I can figure out that the absolute value of velocity at 4 is a negative value, that means it's slowing down and the speed would be decreasing. So with that said, I'm going to get the absolute value function. So I go to math, and then I'm going to go over here to NUM, that stands for number, and then the first one is ABS, that's absolute value. And then I'm going to recall that function that I just typed in. So vars, y vars, function y1, all right, and I'm going to do it at 4. So again, whatever I get from this, if it's a positive value, it's the absolute value of velocity. So if it's a positive value, if this is a positive value, the particle is speeding up. If it's a negative value, it's slowing down. So it's positive 2.9787, which means the particle is speeding up because the speed is positive. Now, for these calculator questions, you have to be careful because you don't have to show a lot of work, but you do need to show enough work that you know what you're talking about. So you need to show that you're talking about the absolute value of v of t, or if you're not going to do that, you at least need to show that you're talking about the velocity and acceleration being the same sign or different signs. So if you don't want to, or if you don't remember to talk about it being the absolute value, if you can show the velocity and acceleration are the same sign, then you can say it's speeding up, or if you can show that they're different signs, you can say it's slowing down. So you can show either one of those two things, but make sure you show enough to prove that you're actually understanding what you're talking about. Part B says, find all times t in the interval when the particle is changing direction and justify your answer. Remember that a particle changes direction whenever its velocity is equal to 0 and it changes sign. So for part B, let's go back to our graph. And I'll type in all, that's not a very good viewing window, but it's too late now. I have to go back and look at a good viewing window. All right, let's try that one more time. So for a viewing window, I know that t needs to be greater than 0, so maybe I'll go from 0 to 10. Let's see what happens. And then I want to see if it's crossing through the x-axis or not. So I'm going to go from -5 to 5 on the y values. All right, so here's what it looks like. And then obviously I was not paying very much attention to the directions. So this is why I tell you guys to pay attention to the directions, because I'm over here wasting time. I need to go from 0 to 3, not from 0 to 10. So let me go back to my window and go from 0 to 3. All right, much better. Okay, so it says, find all times t in this interval when the particle changes direction. This is a graph of the velocity. The particle will be changing direction wherever the velocity is equal to 0, and it actually crosses through the graph. So I need to figure out what value that is. Now, in order to figure out what value that is, I can find it using the zeros. So if I go to second, calc, and I go to 0, which is the second option, left bound, sure, why not? This is on the left of it. Right bound, I need to choose a point over here, so I'm going to choose 3. I'm going to guess, so I think this is approximately like 2.7, so I'm going to put 2.7. And so my guess is 2.7, and in fact, it's pretty close, 2.707. So I'm going to say the particle changes direction at t equals 2.707 because, and so now you have to justify, because if you're not justifying, you're not going to get full points for your answer. So I know that it changes direction because t equals 2.707 is a 0 of the first derivative of v of t, and v of t, oh, the particle changes direction at t equal to, and v of t changes sign from positive to negative. All right, and that implies that the particle is moving to the right and then it starts moving to the left, which is why I know that it's changing direction. And again, I will spare you my over-explanation. So that is also worth 2 points. Parts C and D. Part C says find the position. Remember, we don't know how to do that yet because given velocity, to get back to position, you have to go backwards, which is the integral. And then total distance, again, that has to do with position, so we can't figure that one out yet either. So this is all we can do for number 2.